Hello everyone, my name is Shiddharth from CSC first year. Today in this video we are going to perform an experiment whose aim is the variation of magnetic field due to current carrying coil along the axis, and required aperture is.
This is deflection magnetometer and this is circular coil. This is along the axis and this is the possibility of selecting the number of terms in this circular coil. We have this four adjustment. This is commutator and this is ammeter. This is battery eliminator and this is plug key.
Now coming to the procedure part of this experiment, first we switch on this board and we switch on the regulated power supply and set the value to the 50 milliampere as you can see. Now we plug the key in the clockwise direction and we now note the deflection of the magnetometer or to both end of it. As you can see, the deflection, it is around 30 degree. And now we change the direction of the current and now we plug off this key and put it like this as the direction of the current of the change, and it became the reverse of its original direction. And now we again measure the deflection on both end of the magnetometer as you can see. Now we put the magnetometer and put on the 5 centimeter toward the right of the circular coil and note the deflection as you can see. And we now again change the direction of the current by plugging the key and put it like this. And we now shift this magnetometer toward the left of the circular coil and place it on the 5 centimeter as you can see. And now again we change see the data, and in similar manner we can change the direction of the current. Now for this we plug this key and now we put the key like this and we see the data. In similar manner we can perform all this scaling and notate the data. Following the data we get while performing the experiment, for this we have the chart, and here we have the distance of the needle from the center of the bench. We have the deflection of on the left side of the coil in degree. We have deflection on right side of the coil in degree. For deflection on left side of coil in degree we have two current, direct current and reverse current. And for direct current we have two angle, theta 1 and theta 2. For reverse current we have similar like theta 3 and theta 4. For distance of the needle from the center is equal to 0. For direct current the theta 1 value is 30 degree, and for the similar direct current theta 2 value is 30 degree. And for reverse current we have theta 3 and theta 4 as you can see. For this now we take the mean of the all these theta that we are obtained from the experiment, and on taking the mean we have 30 degree. Now we find the value of 10 theta and put the theta mean here, and while putting the theta mean here we have 30 degree, which is equal to the 0.57. and similarly we can perform all this data and we get the value of 10 theta, and we noted the data in the following manner. Now coming to the observation part of this experiment, we have the circumference of this coil measured by a thread and meter scale. We measure it manually and it came out to be 68.5 centimeter. And we have the graph of x tan theta. We have x on x-axis and tan theta on y-axis. We get the following graph, and the graph is came from the data we got from the experiment. Now we come to the calculation part. We have the radius of the coil AB as measured from the x tan theta graph, which is equal to the 10 centimeter, and we have the radius of the coil from the measurement of circumference, which is equal to circumference by 2 pi, and it came out to be 10.90 centimeter. Now we calculate the percentage error. For the percentage error we have a standard value minus calculated value divided by standard value into 100. While calculating we have error equal to, we have a standard value 10.9 and calculated value we have 10, and standard value by 10 divided it by 10.9 and multiplying it by 100 we have 8.25%, and this is our percentage error, and this is our final conclusion of this experiment.